First step, always first step, identify longest carbon chain. We're going to identify our root here. How can I make a line here in example number 1 and include as many carbons as possible? I'm going to have 5 carbons here. We would call that pentane. Pent meaning 5, and ane coming from alkane. Now I could have chosen this bottom methyl group when I drew that green line. I could have went 1, 2, 3, 4, and went down. I'd still have 5 carbons. But when I can split off in equal groups into a methyl group, or any group into that equal group, it's not going to matter. Prove it to yourself. Try and name this with this green line, and then name it had I drawn something down here. You'll see that it's the exact same name. And you'll be able to recognize that better with more practice. Pentane is my root. I have 5 carbons. Now I'm going to be looking at what is not included in my carbon chain. And that's going to be all of my substituents. Everything that's not in my green carbon chain, those are going to be substituents. I have 1 methyl group here. Methyl group because it's 1 carbon. And 1 methyl group over here. 1 methyl group because there's 1 carbon. Memorize that chart if that does not make sense, or watch the video before. I have 2 methyl groups, and let's see now what position that those methyl groups are going to be in. They can either be in position 1, 2, 3, and 4, or they can be in positions 2 and 3. They should be positions 2 and 3 because I want to minimize the numbers that my substituents are in. I'm going to number my root from right to left so my substituents get the lowest number possible. All right, let's name this thing. I said I have 2 methyl groups at position 2 and 3. How I'm going to do that, and let me color coordinate this. So substituents are going to be in orange, and my numbers, keeping consistent with the last video, will be in red. How I'm going to name this is first start out with the number. I'm going to have 2, 3, signifying that these substituents, the same type of substituent, that's important, are in positions 2 and 3. And what I'm going to do, because I have 2 methyl groups, I'm going to say this is 2,3 dimethyl pentane. And that will be the name of this compound. Di means that there are 2 methyl groups overall. The numbers tell you where those 2 methyl groups are on your chain. The methyl indicating you have 1 carbon substituents, and pentane saying that your root is 5 carbons long. If you didn't get that, that's okay. Don't expect you to get alkanes in just 2 tries. Let's get some more practice with this. First step, what's it going to be? Name the carbon chain, identify longest carbon chain, and we can name the root right away. Let's do that in green, keep things consistent here. Longest carbon chain here, I'm looking at this, maybe I can go 1, 2, 3, 4, 5. There's another way I can do this, 1, 2, 3, 4, 5, 6. That's a longer chain. I'll outline this in green. My longest carbon chain. There we go. All right, identify substituents. Everything that's not in green. I have 1 carbon sticking out here. We should know that that is a methyl group. Let's put that methyl group on the lowest number possible. We're just moving down the steps outlined in the previous video. Root, substituents, numbers. I'm going to number my carbon chain from left to right. That way my methyl group is in position 3 rather than position 4. Now I only have the 1 substituent, so I'm ready to name this thing. My root, and typically I like to name these things backwards usually. It follows the order I believe is easier. when you first look at a compound. So I'm going to start with the root. 6 carbons, we should know that that is hexane. Go. I have one substituent on carbon number 3. That substituent is a methyl group. Methyl. And we said that that was on position 3. I don't need to worry about other numbers because I only have one methyl group here. And I don't need to say unimethyl group. That's implied that there's just one methyl group. If I had 2 methyl groups, I would indicate the numbers out here where they're at and say dimethyl. If I had 3, I would have 3 numbers out here and say trimethyl, and so on. Get some more practice here. Keep going. Again, try these on your own if you haven't already. Try them on your own and we will go through them together. All right, we're going to get into example number 3 right here. Continue with the order. Longest carbon chain is going to be first. So let me identify that. I could number these 1, 2, 3, 4, 5, 6. Let me make sure there's not any other things that might interfere here. 1, 2, 3, 4, 5, 6. So now I have a decision to make. Which carbon chain should I choose? I could choose the green one. And again, it doesn't matter which methyl group I pick at this point because they're the exact same. Or I could choose the orange chain. 1, 2, 3, 4, 5, 6. They're both 6 carbons long. The only way that they differ is notice that my orange chain here would have one large substituent, this isopropyl group. Isopropyl group, an isolated propyl group, 3 carbons long, right here. The green chain instead would have one methyl and one ethyl group on it. Now I've seen videos out there that say that you want to, and this is wrong, that you want to minimize the number of substituent groups. IUPAC wants you to maximize the number of substituent groups. So it actually makes more sense to have a lot of small and more common substituent groups than one large, tough to name one, like an isopropyl group for a lot of beginner students, a lot of beginner OChem students. So the orange one is incorrect because it only has one large substituent. So we're going to erase that one. And instead, we're going to choose the green as our longest carbon chain because it maximizes the number of substituents. You'll see some videos out there that are incorrect in saying that you want to minimize. You want to maximize the number of substituents. Next up is identifying those substituents. I have a 1 carbon, so everything that's not in green. A 1 carbon substituent here we would call a methyl group. And down here a 2 carbon chain of which we would call an ethyl group. So 1, 2 carbons there. I have a methyl group, I have an ethyl group on my carbon chain. So I have the root here, 6 carbons, and an alkane we're going to call hexane. And I've identified my substituents, and we can put numbers associated with them. Here is your first example where you have multiple substituents, different kinds of substituents. Let me show you what you do. You're going to order substituents at this level when you're dealing with alkanes in alphabetical order. I have a methyl group, I have an ethyl group. Ethyl, E, comes before methyl, M. So ethyl is going to have priority here, alphabetical order. And my ethyl group will come first, followed by my methyl group. I'll finish with my root. I'll show you. So if you watch the introduction video, I had those brackets around that kind of orange and red part. That's to show you that all of these substituents, okay, are going to line up front. So I have 2 different kinds of prefix, two different kinds of substituents outlined here. Here's what the number, my ethyl group, the number of my methyl group. Again, I'm choosing my ethyl group first because it comes before M for methyl group. Alphabetical order here. What position, carbon position, is my ethyl group in? Well, I should number my carbons to get the lowest number possible, right? I'm going to number this thing from right to left. That way my substituents are in position 2 and 3 rather than 4 and 5. So make sure that those numbers are lowest position possible. I'm going to do my ethyl group first, alphabetical order. The ethyl group is in position 3. 3 ethyl. And I should continue to put dashes between each of these. My methyl group is in position 2, right here. So I'm going to say 2 methyl. And I'm done with my substituents, finished with my root. This molecule here is 3 ethyl, 2 methyl hexane. And with enough practice, you'll be able to read this and draw it. But it'll take some more practice. Let's get some more practice here with number 4. Try it on your own. Follow the steps, use the chart if you need to. Longest carbon chain here. We'll do this one quick. Longest carbon chain, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. This is going to be my longest carbon chain right there. 8 carbons. We call that octane. And there's our root. Our substituents, everything not in green. 1 carbon up there, methyl group. 2 carbons right here, ethyl group. Methyl group, ethyl group, what positions are they in? Well, I could name them 1, 2, 3, 4, 5, 6, 7, 8. That would put my methyl group on 4, my ethyl group on 5. Or I could do 1, 2, 3, 4, 5, 6, 7, 8. Both of my groups are going to be 4 and 5 no matter what. So what's the tiebreaker? Ethyl group comes before methyl group in the alphabet, right? E comes before M. So we're going to prioritize our ethyl group here. And what we're going to do is put our ethyl group on position 4, our methyl group on position 5. Very rare tiebreaker, but just want to make sure that I'm covering a lot of these just in case type of scenarios. So I'm going to put my ethyl group 1, 2, 3, 4, 5, 6, 7, 8. I'll put my ethyl group on the lower number just because it's before methyl in the alphabet. That's only going to do that when they happen to have the same numbers, right to left or left to right. Because notice, if I were to number them left to right, my substituents would have the same magnitude, same 4 and 5. Again, it's rare, but want to make sure I cover it. We're ready to name this thing. I mean, I have a 4 ethyl, 5 methyl octane. 4 ethyl, 5 methyl octane. That's going to do it for this video. Thank you for watching. Like the video, subscribe to DentChem, get some more help with OChem for free. Some other things you can do in the meantime, find a whiteboard like this, find someone else to work with, and create your own problems. Those things, along with watching DentChem, is what's going to help you the most, help you succeed in organic chemistry this year. Thanks for watching.